Okay, so today, the next topic that we have to discuss is how to solve rational equations. So that's these are basically equations involving fractions. So let me just like write like a couple of examples, and then I'll kind of give you like the general strategy for solving things like this. So here's one. Here's some examples. This are 0. This is another example. You could also have fractions both on the left side and the right side. So here's another one like okay. Let me put another one. I mean, so basically, like I'm just putting a bunch of like different examples of like these types of equations just to show you that there's no shortage of them. So like you can have situations where only there are fractions on one side of the equation like this, where it is being equated to 0, that's fine. Where like there are fractions on both sides, that's also okay. Where like there are like sums, differences like of fractions, like more or less like anything can happen. There's no like real restriction on on what you can put. Like the only condition is that it involves fractions because that's what we're trying to solve. So essentially, and this is why we spent some like a lot of time doing that yesterday. Like the idea to solve like an equation that involves fractions is to first of all, and I'll write the steps in a second, but first of all, you want to play with the terms so that you have a single fraction on each side of the equation. So the goal is to get to something like this. This is like the presentation that you want for this equation. So you don't want to see something like this where there's like a bunch of fractions being added or subtracted. So you want just like a single fraction on the left side and a single fraction on the right side. Okay, so let me write that down, and then I'll kind of do some examples to show you how this is supposed to work. So how to solve rational equations. Okay, so essentially, what you want, the first step is to combine the fractions that appear on the left side into a single fraction. And you do the same for the right side. And then you do the same. Okay, so maybe it's a good idea to do it in one of these examples. Just to show how this will look like. So let me see if we have one that's nice and super long to do. So here's how can I take one of the that's slightly simplified. I'll take kind of like almost the same, yeah, just to make it a bit faster, let me erase one of these terms. Just spend too much on this one, but I'll put one over X here. Okay, so, like an equation that you're trying to solve could look like this. Okay, so hopefully it won't be that bad. Like we'll have to check it out to see whether it works or not. I can actually let me yeah, because I don't want something cubic, so I'll put here like that too. Okay. So So what you want to do is like, you have three things on the left side and you want to, and you have two things on the right side. So you want to combine the left side into a single expression and a single fraction. And then you want to combine the right side, these two terms into a single fraction. Okay, so let's try to, like, you can do it separately if you like. So that it's not so messy. So let's start with the left side. That's why we practiced like this yesterday. So if you have something like this, what do you need to do? To combine fractions, you need them all to have the same denominator. That's the key. So here, how can you make this the same denominator? So like the first term, what is it missing? Like it's missing an x squared. That's the highest thing, the highest power of x that appears in all these denominators. So that's what you're missing here. Put x squared over x squared. What is the one in the middle missing? So the denominator in the middle is like it's like an x away from getting to x squared. So you multiply and divide by x for the one in the middle with different colors. And there's nothing missing, like, or nothing, there's nothing needed in particular for the last term. So like, I don't have to multiply that one by anything specific. Okay? Does that make sense? So what do you get here? So like the numerator of the first term becomes two x squared over x squared plus, okay, the numerator, the first in the middle one becomes x, and the denominator is now x squared. And the last one is minus two x squared. Okay. So once they all have the same denominator, you can just like do like the addition and subtraction like in the regular way. So like you can get two x squared plus x minus two. Okay, so that is how the left side looks like. Um, Now let's look at the right side of the equation. So the right side is one over x. Okay, so before combining, like the recommendation is to factor out as much as you can at the denominators to see what's really missing in each of them. So I'll rewrite this as one over x plus 5x. What can you factor out here? Like you can factor out an x in the second denominator. So like x times now. Okay. And then you kind of do the same game, like you just check what each term is missing. So 1/x, this fraction, this denominator is missing the term x minus 1, so you multiply it and divide by x minus 1, top and bottom, so like x minus 1, x minus 1. And the second has everything that it needs. So like there's nothing left needed for this one. Okay, so these will give you x minus 1 over x times x minus 1 plus 5x over x times x minus 1. And when you add up this x with this 5x becomes a 6x. So you end up with 6x minus 1 over x times x minus 1. Does that make sense? So in the end, like just kind of like once you look this equation, what happened in this equation after doing the combining of the fractions, after combining terms, like this equation ends up being the same as the following. Like the left side becomes 2x squared plus x minus 2 over x squared, and the right side becomes 6x minus 1 over x times x minus 1. So any equation that you have that involves fractions, you can always combine terms so that you have like a single fraction on the left side and a single fraction on the right side. Okay? So what do you do after you get to this step when you have a fraction on each side of the equation? The next, what you do after that is to, you know, what you do is basically to multiply both sides of the equation by the denominators that appear on each side. So basically, you want to get rid of the denominators essentially. So let's call this step 2. Well, actually, before like saying step 2, basically what's happening, like I don't know if you remember, like you'll get to so here's like a property of fractions, which is like the one I'm about to use. That if A over B is the same as C over D, then A times C, sorry, A times D is the same as B times C. Right, like you can't cross multiply fractions. Let me kind of like show you quickly why that works. But like the idea is when you have fractions, like when you have an equality between fractions, like that means that the first numerator times the second denominator must be the same as the second numerator times the first denominator. So why is that true? Because how do you like, how can you remove like the denominators? Like like say, for example, you can multiply the equation by b, okay? And a over b times b. You can multiply both sides of the equation by the same number. So you multiply both sides by b, okay? So that gives you, what happens after you do that? You get like that, this b kind of now appears top and bottom, so it goes away. So you get a equals c over b times b. And then to get rid of the second denominator, you multiply both sides by b. And then which is, well, it's the same as what I have here. So essentially, what I'm trying to say is like, let's call this cross multiplication. Like you can multiply terms like as like in an X basically. Or like here you have like A, B, C, D. So A gets multiplied, you know, A gets multiplied with D and B gets multiplied with C basically. Uh, So why is that useful? Because like you never want to solve an equation if they're like denominators. Like that doesn't really work well. So by doing this, like you can get rid of the denominators. So essentially, let me write it here because I don't want to erase this stuff because that was the original equation. Um, so in step two, step two is that after you have a single fraction on each side of the equation, after you have, once you have a single fraction on each side of the equation, you cross multiply to remove the denominators. You to remove the denominators. So, for example, in this one that we were working with, which is 2x squared plus x minus 2 over x squared equals it's x minus 1 over x and x minus 1. Um, you know, kind of like these two go to, it's kind of like a diagonal thing. So these two go together and then do 2x squared plus x minus 2 times x times x minus 1 equals, what is like the other one that we get here? You get, x squared, that just takes it 1. That makes sense how I got to like an equation without fractions. Okay.
Would it be nice to combine the x times x negative 1 together?
Oh yeah, you can, yes, like, that's what, like, if you want, you can rewrite this as x squared minus x, yes. Which actually you do need to do eventually if you want to start simplifying this further, right? But if you just care about like kind of like putting it as a single equation without denominators, then this is fine. But yeah, like the next step would kind of like just do basically what you're saying, because, first, like, okay. In practice, I wouldn't give you an equation that actually ends up looking like this because it's like a little bit of like a brutal equation because like it's degree 4 basically. So this is like an x squared, and this will have like an x squared. So this will give you x to the 4. And essentially, like, there's no expectation whatsoever that you need to know. Like, I mean, God knows like you get kind of like a quadratic equation after you do this, like for the examples I'll do today that I'll give you. So this is like a little bit more complicated than the type of equation I will give you. But yeah, like at least I'll kind of simplify it for you to kind of like get a sense of how it looks like. But the idea would be to kind of like rewrite it so that it kind of is equated to 0. So you have to play with the equation so that it equates to 0. So let's do that. But again, like for the ones that we work with, like it will be like quadratic mostly, so that it can be easily solved. Because like solving a quartic equation is like a pretty big effort. Like there's no real course like usually that goes over that. That's kind of more like I mean it can be done, but like it is complicated. So like then like step 3. And it's kind of like at least a good exercise in like working with distributive properties and other things to see how this looks like. So step 3 is to, simplify each side or rewrite you get an equation for x, you get an equation for x not all. Okay. But with the right hand, with the one of the sides of the equation being 0, that's the important thing. With one of the sides, one of the sides of the equation being 0. Which typically is the right one because like, so like, the convention is to have like the right side equated to 0. Each one of the sides of the equation being 0. So just to show you how this looks like in this particular example, for this, I'll continue using those colors. So for the left hand side, you will have something like 2x squared plus x minus 2. Then it kind of makes sense to simplify this a little bit by doing the product. So you get x squared minus x here. Okay, and then the right side on here is like we have 6x cubed minus x squared. Okay. And then it's kind of like a bit annoying, but yeah, if to get to an equation like equated to 0, like you can distribute this first to which is like a little bit okay, this one with this one gives you 2x to the 4, then this one with this one gives you minus 2x cubed. So this is like a good practice in the distributive property. Then you do the one in the middle with this one, which gives you x cubed. The one in the middle with this one gives you minus x squared. And this one with this one gives you minus 2x squared. And this one with this one gives you plus 2x. Okay. Which again, I can practice, you wouldn't need to solve something as complicated as that, but I'm kind of showing you how it will look like. And then, sorry, let me draw. And then, like before, like again, you want to set it equal to 0, so you have to move this to the other side. Okay. but before that, it's kind of like useful to kind of like simplify terms like here, so. This is two x to the four, and then what has x cubed here, like this one and this one, and that gives you minus x cubed. What has like an x squared, these two terms have like an x squared, so it becomes minus three x squared. And this is equals to x. Okay, so that is what the red stuff looks like. And then what you can do, to set it equal to 0 is like subtract like these things. So you do like. And so like you end up getting an equation for x, which looks like this. This with this gives you 7x cubed. And then this with this gives you minus 2x squared. Which is a horrible equation to solve. Again, like, you wouldn't need to solve something like this. But it is kind of like the layout of how it would look like where you just set it equal to 0. So like, again, well, like the other examples I'll do can actually be solvable like more easily. But the important thing here is that once you find the values of x that solve the equation, like, and that's the last step. So step 4, which is once you find which solve the equation. You double check, it's similar to the problems that we were doing with the square roots. You must double check in the original equation that it works. You must check that this value works in the original equation. You must check. Which of those values, like, because we could find more than one. Solve the equation that had the fractions, like solve the equation when it was written in using fractions. Solve the equation written with the fractions.
Can be simplified further, right?
You mean this particular one?
Yes.
Like the most you could do is to factor out an x. That is like kind of what the easiest thing to do. Like, so actually that's where I was going to go at. Like, so if you factor out an x, you get 2x cubed minus 7x squared minus 2x plus 2. Right, equals 0. Now the cubic part, yes, I wouldn't like, I wouldn't expect you to know how to simplify this further, right? So that's why I was saying that usually the most that you get to see is kind of like a quadratic equation, because like those we do know how to factor and do other things. But at least if you do this, like you can see, like what I wanted to say about this example is that if you look at it, at least it makes it clear that x equals 0 would be one of the solutions here, because if you take x to 0, like you get 0 times whatever, and that kind of solves the equation. So in this example, x equals 0 is a solution. But that's what step 4 refers to, like if you go to the original equation involving fractions, having x equals 0 is kind of like problematic because that would give you 0 in the denominator and that's not allowed. But like so, but as that is an issue for the original equation, that is a problem. Since there cannot you cannot have a denominator become 0. Okay. Since a denominator, no denominator can become 0. So now I'm going to do kind of like a more realistic example to show you how like all the steps look like. But that is important to double check here because it can occur as you're doing the problem that you find some values for x that solve this version of the equation, but not the original version when they had the denominator. The reason for why that happens is that when you have it in the denominator version, there are values that are forbidden just because like the denominators can never become 0. But here, they're like, when you look at this equation, there's nothing like in principle wrong with any value for x. Like it kind of like it always makes sense. It may not be true whether it's equal to 0 or not, but at least this formula always makes sense for any value of x. Whereas these formulas with the fractions do not make sense for all values of x because like 0 can never be like the denominators can never become 0. Yes.
Do we have a, assuming this is wrong, but
Mhm.
do we have a move the 6x -1 over x times x -1? We have moved that over to the left.
Mhm.
That would make it negative, then we multiply x2 to the other fraction, and the x times x -1 to the other side.
Uh,
Basically trying to make the fractions or the denominators equal by moving the right to the left.
right. You could have like, yes, like you could have like, you could like have like, yeah, move this first and then like, right, like have a common denominator. Correct. But
That's the same thing.
it will give you the same equation, yes, like eventually, yes. No, like, but yeah, like that's a fair point. If you wanted, like, you could kind of like work with a single fraction from the very beginning, like, but yeah, by moving everything, but it won't, you will, get to, regardless of how you do it, like, you would get to this equation for sure. Um. Any other questions? Okay, so let me do a more, realistic example. Like where you can see all the steps like taking place together, but like this is like one of like again it's similar to the equations with square roots. It is like a long process, but you do have to be patient when you're solving it because there are many steps involved. It is more or less like the last topic for the course because there are many things that are occurring at once. But let me start. Let's do this one because it's kind of nice. So you'll see a lot of stuff taking place. So. Okay, let's try to work this one out. So the idea here is to, again, have a single fraction on each side of the equation. So we'll get to that. The right hand side already has a single fraction, right? So there's nothing left like needed to be done here. But for the one on the left hand side, you do have to combine first so that you can have like a single fraction. So let's try to work this out to see what's going on. So what is the first fraction missing in the denominator? The first fraction is missing an x minus two. So I'll multiply by x minus two, top and bottom. Here it is important to remember to use parentheses, like just to not make it look too confusing in the equation. So um, it does help you a lot to, if you keep track of the parentheses for this type of problems. And then let's see. What is the second one missing? Like the denominator, this denominator is missing x minus four. I'll put x minus four here. Okay, and since like the second, like the right hand side, it was already good to go. I'll just rewrite it. I'll just rewrite it as it is because like there's nothing to be worried about here. That makes sense. Okay, so what is happening here? So you have to multiply the, like, now you do these products. Um. So let's think about this one first, like you have x plus two times x minus two. I don't know if that rings a bell in terms of like any identities. Does that sound familiar? X plus two times x minus two, the name for this one. Is is similar to x power minus one, but what is the name for it? But yeah, it involves squares, right? But it's okay. So you kind of nailed it. Like it has to do with squares. Like the name has squares, and there you said minus. So
Difference of squares?
yeah, it's a difference of squares. Good. So perfect because this is kind of like a plus b. You have like here like a plus b times a minus b, right? And that is like the difference for formula is a squared minus b squared. So yeah, I'm good. Which by the way, like, if you don't, you know, remember it, that's totally fine. You just distribute or FOIL and you'll find the same, but it does save you some valuable time if you kind of recognize it. And this is actually an important formula. Like that's probably like the most important formula of the course when it comes to like things with quadratic stuff. Like that, yeah, like memorizing it is like a good thing to do. So if you do that, this is like a is x here and b is two, so you get x squared minus two squared, which I'll write as four in a second. And then this is x minus four times x minus two. And the nice thing about the other one is that it's also similar, it's like a difference of square formula, a plus b times a minus b. So this one gives you a is x now, so it's x squared, and b is four in this case, so it's four squared here. And then this is x minus two times x, sorry, x minus two times x minus four. Okay, and this is all equal to x minus two over x. Okay, is that making sense? So like, let me do like again, like here, it's better to do every single step, even if you look just like very basic arithmetic, because like the risk of like making typos is high. So like I'll write every single step, even like if it looks like a bit of an overkill. So like this is x4 minus 4. Let me combine them all with a single denominator already, because that's what we did this for. And then I'm going to subtract this. This is a 16. And this is like, again, like important word that this is why parentheses are useful, because like this minus is affecting every term in this parenthesis, right? So when you multiply by negative, like if this will change the sign of each term inside the parenthesis. So let's see what happens here. Like, so this becomes 3x squared minus 12, and then this minus sign affects both terms, so like minus x squared, and then flips the sign for the other one plus 16. Okay. And then before, okay, so like here it looks a little bit messy. So let me, this with this gives you 2x squared. And the 12 with the 6, and minus 12 with 16, that is plus 4. So okay. Questions up to this point, because now we're about to do the most important thing, which is to make it a single equation, right? Like not a single equation, sorry, I meant like without denominators. Um, Now, before doing that, like there's something like hopefully you will notice, because it will make your life easier, which is to notice like there's an x minus 4 on the left side and the right side of the equation, right? Like in both denominators. So what you can do, for example, is to multiply by x minus 4 on both sides before doing any further simplifications. So let me do that. So multiply by x minus 4 to kind of like cancel it if you want to just think about it in that way. So like, I mean, it's kind of one of the properties, but yeah, one of the denominator factors appears on both sides, then you can remove it. So these will give you actually, you know, x squared plus 4 over x minus 2 equals, x minus 2 over 1, like that's the only thing that's left in this, like, in the denominator. Okay.
Could they cross?
And then now you can cross multiply. Yes, exactly. Like it's just that you could have cross multiplied here, but it's like a messier multiplication, because then you have to multiply all of this by x minus 4, which really is unnecessary, because it would go eventually away if you were to start simplifying. Okay. So once you get to this step, you can cross multiply. So like the yellow one, which is 1 times 2x squared plus 4. Okay, that one is easy because it's being multiplied by 1. That's not really, that's it. I mean, we do the same thing. And x minus 2 times x minus 2 is x minus 2 squared. And now that it like here, and we're almost there. You know, it's just that you have to expand this out. And again, like you could just distribute to find it, or you could just use like this like important formula, which is like together with the difference of square formula, like probably like the top and the top three of formulas, which is a minus b squared is a squared minus two ab plus b squared. This is binomial formula. That's how it's called. So what happens if you do that? Like the yellow, like left hand side is just like two x squared plus four. That's fine. What does like this formula say about the second term on the right side? Like you said, square the first term, then do twice the product, but it's like with a minus, minus two x and two. Okay, and then add the square of the last term or the second term. So it's two squared. So you get two squared plus four. Equals x squared, so this becomes 2 times 2 is 4, so it becomes minus 4x plus 4. Okay. And then now, okay, this is like, if you compare this one with the original one that I did at the beginning, which was like degree 4, like this is like friendlier. This is kind of like the type of equations you'll see. It will always be kind of quadratic if you simplify correctly, because then we do know how to solve for quadratic equations. So like to solve for quadratic equations, like the things you cannot solve it in this format, you have to move everything to one side of the equation. So like, let me just like keep like, continue with the color. And so I'll just move everything here to the other side, so like this goes as minus x squared, this flip sign will become four x. The other one changes to negative four, right? That's what happens if you kind of subtract the like corresponding quantities. So that's going to get zero here. Okay, and now this is not too bad, like because this two x squared minus x squared becomes x squared, then you get four x here. And then 4 with negative 4 is a 0. I'll just put it explicitly, although it's not needed, but just to emphasize that that's what happened with the force. Like because there's a 4 here and then a negative 4 there. Is that okay? And how do you solve this? You factor out an x, so you get x times x plus 4 equals 0. When is the product of two numbers equal to 0? One of the factors must equal 0. So one possibility is for x to be 0. So or x plus 4 could be 0. Which that one gives you that x equals negative 4. Okay. Neither, okay, so this step, what you have to think is like, okay, is this a problematic value or not? So you have to think, what if I log x equals 0 in the original equation? Does that make any of the denominators 0? And you see that it doesn't, like, because you put 0 minus 4, like that's negative 4, 0 minus 2 is negative 2, and 0 minus 4 is negative 4. So x equals 0 will not make any of the denominators 0. So let me write it here explicitly. So none of the denominators become 0 with x equals 0. So what that means is that that actually solves the original equation. So it will solve, so it solved the original equation. And what about the second? So for example, if this had been 4, if this had been 4, then we would have had like an issue because 4 minus 4 is 0, right? But negative 4 minus 4 is negative 8, so that's fine. and then -4 minus 2 is -6, and -4 minus 4 is -8. So because it was with the minus and not a plus, we were safe. Like if it had been like a negative, this had been a 4, then we would have been with problems. So none of the denominators become 0. X equals -4. So this also works. So this also works for your, this value solves the original equation. But notice, for example, x equals 4 would have been an issue, or x equals 2 would have been an issue. So if we had found one of those two values, and like we could not have used them for the every part. X equals 4 or x equals 2 would have been problematic. If given issue would not solve the original equation. Have we found that? So once you find the values for x, what you must do every single time is double check that like none of those values make it an issue. Okay. I'll give you some like after the quiz, I'll give you some problems for you to work on. But essentially, it will always have this strategy. You combine every term, every sign into a single fraction. Once you have a single fraction, you remove the denominators to have just like an equation for x like in here, which will be quadratic for our purposes, because like that's kind of like the things that we know how to solve. And then you double check that those values, whether they work or not. Okay. Yes, or you go to
Actually, after.
okay.